Okay, so by the time that you are watching this video, we have reviewed three strategies for solving quadratic equations. The first strategy was you learned how to factor with basic quadratic functions, then you would use the zero product property here. Okay, so with the zero product property, it's that x and the area model. So I'll just draw this because I believe you all recognize this. We've used it so many times. The next thing that we learned was just last week, just recently, completing the square. So it's not factored as easily. If we're doing this, it means that whenever we try to factor the quadratic like normal to use the zero product property, it did not work. So like we had some number up here and some number down here that just no two numbers that multiply to the top would ever add to the bottom. So it just does not work. And that's whenever we go and see, okay, well, what about completing the square? Well, there are two things that are super important. The coefficient of x squared must be 1. And I'm going to add a little thing here to make your lives easier because I know a lot of you don't like dealing with fractions. So your b term should be even. It does not have to be. It would still work if it was odd. But the b term should be even. So like 2, 4, 6, 8, 10, etc. So what I mean by the b term, just to remind you, is we have a standard form of a quadratic is ax squared plus bx plus c equals 0. And it's equal to 0 because right now we're talking about solving quadratics. Whenever the y value is 0, that means we're solving for the x-intercepts. That's the whole point of this, is to find the x-intercepts. Okay? Now, just recently, we started talking about the quadratic formula. This literally works for any equation whatsoever. You must rewrite the equation to be in standard form if it is not in standard form whenever you start to solve the problem, because you have to identify A, B, and C in order to use the quadratic formula. So this formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so that is the formula. So let's go ahead and take a look here. I did add on one quadratic equation here. If you would please add this to your notes. It's just x squared plus 6x minus 8. So the first strategy you want to try is the zero product property. So what I would do to try this right away is I would start off by drawing my x. I multiply negative 8 times x squared to get negative 8x squared up top. And then the 6x, if you guys remember, the 6x is the bx term that goes on the bottom of my diamond. Okay, so I have 6x. So we have to find two, oops, I totally wrote a bad equation here. Ignore that one. Sorry, guys. This guy has to be a positive 8. I'm sorry. Let's see here. Miss Champlin. So we have 6. Yeah, let's do this. So negative 6x and a positive 8. That's what I meant to do. I see my mistake now. So positive 8x squared on the top. Make sure that your equation is x squared minus 6x plus 8 for me. Okay? And then that negative 6x is going to go on the bottom. All right, so now we have to find two numbers that multiply to positive 8 but add to negative 6. Okay? So let's just draw a little factor chart of 8. We know 1 times 8 would give us 8 and 2 times 4. So if you look here, which of these combinations could possibly give us a 6? I think you all are pretty solid at basic factoring. If you're not, definitely reach out to me and say, hey, I need a good review on basic factoring, and I'll try to direct you to some helpful resources. So 2 times 4 is 8, but 2x plus 4x is not negative 6x. These both need to be a negative. Negative times a negative will give us a positive 8 up there. But negative 2x plus negative 4x will give us negative 6x down here. So that's good. So this means strategy 1 works. I can use the basic factoring and zero product property. So now I can set up my area model. Okay, I'm going to zoom in a bit. All right, so I'll just go ahead and color code here a little bit to help you out. We always want to put that first term and the third term across from each other. It doesn't really matter. I could have used these two boxes or these two. It doesn't matter which two as long as they are diagonal from each other. So we have x squared and 8, and then these two here, negative 2x and negative 4x. So now we can factor that. This column's GCF is an x. This column's GCF is a 4. Whoops, 4. This row here is an x. And this row here is a 2. But you realize here that x times 4 is positive 4x. So that 4 needs to be a negative. And same thing with this 2. It needs to be a negative. And then you realize, okay, good. Negative 4 times negative 2 is positive 8. So we're good to go. Remember to pause these videos if I'm going too fast for you. It is a video, so I'm going to go at a faster pace than I would in class because you have the ability to pause and rewind. So now we have x minus 2 times x minus 4 equals 0. So we can use the zero product property to split these both up, set them equal to 0, each of them. So we add 2 to both sides here. We get x equals 2. Add 4 to both sides here. We get x equals 4. And these are our solutions. These are our x-intercepts. So that one worked out nicely with this area model in the diamond, the X diamond, X box. I don't know what we really call it, the X, to where we can factor. Okay? I need to come up with a better name for whatever this is. But maybe you guys will just know it as whatever this is. I don't know. All right, so let's go ahead and look at this next one. You'll see that the numbers are quite a bit bigger, especially that 57 there. So we're going to first try the zero product property. So what we're going to do here is I'm going to make that blue. We're going to do the x here. 57 times 3, 171, and it's a negative. And then we have a negative 10 on the bottom. I don't know about you, but just looking at this makes my head hurt. And 171 might be a prime number, which means it's not divisible by anything besides itself and 1, right? You could start plugging in different numbers, but 10 is only divisible by 1, 10, 2, and 5. 171, actually, so these would be adding. So 10, there are plenty of different ways to get 10. Guys, I'm so tired, just a heads up. But looking at this, it hurts my brain. And I'm like, I don't even want to deal with this. So strategy 1 is just not going to work for us for this one. So let's look and see, is strategy 2 an option? B is an even term, so that's good. But this 3 tells me I cannot complete the square. It has to be a 1 in front of the x squared. So you might just see it as x squared. That means the coefficient is a 1. So we cannot complete the square here because of the 3. So we must use the quadratic formula. So I'm going to number these strategies here. Strategy 1, 2, and 3. Okay. So we're going to use the quadratic formula. So I'm going to go ahead and take this and copy it on over. Okay. So we're going to highlight a little bit because we need to find A, B, and C. Now I'm going to go and zoom in a bit here. All right. So A is where the 3 is. That is the A term in ax squared plus bx plus c. A is right here as well. The negative 10 is our B. So that's where the B's are going to go. And then the negative 57 is our C. Okay? So I'm going to go ahead and also set up this little thing here with each of my colors. So this is always your first step, is to write out the formula and identify A, B, and C right away. So we know A equals 3, B equals -10, and C equals -57. And again, this is just because ax squared plus bx plus c is the standard form of a quadratic equation. So you see here C, A, and B. Okay, so this is how we identify it. Once you're able to get A, B, and C, now you just plug it into this formula. Okay, so whenever we do this, I'm going to write x equals -10 instead of the B, plus or minus the square root of -10 squared instead of just B squared, minus 4 times 3 times -57. That's going to be a big number. All over 2 times 3. Okay, so now we start to simplify. This negative times -10 is going to become a positive 10 because this is technically -1 times -10. So here we have positive 10 plus or minus the square root. -10 squared is -10 times -10, that is 100. And then here we have -4 times 3 times -57. I multiply all of these at once, and I definitely need a calculator for this one. So I'm going to go ahead and go into Desmos Scientific Calculator. We have a -4, and then parentheses 3, parentheses -57. I got 684. Okay, plus 684, because that was a negative times a negative. The 4 and the 57 were both negatives. All right, and then it's all over 2 times 3 is 6. So now what we have to do is we have to simplify 100 plus 684. Okay, so this is 10 plus or minus the square root of 784 all over 6. So now we have to see, okay, is this a perfect square? All right, sorry about that. I lost my video. I accidentally closed my iPad screen for some reason. Okay, so we have to figure out if 784 is a perfect square. So I'm going to go ahead and go to Desmos again and take the square root of 784. And it is a perfect square. We got a whole number, no decimals. It is 28. So now that's really nice. So now what we can do is write, we know x equals 10 plus or minus 28. The square root of 784 is 28 all over 6. So now we can go through the process of splitting the plus and the minus. So we're going to have x equals 10 plus 28 divided by 6, and x equals 10 minus 28 divided by 6. So again, the split and those plus and minus came from that plus or minus that was in front of the square root sign before. So this is going to be 38 divided by 6. And we'll round that in just a minute. And this is going to be -18 divided by 6, which is just -3. And this one is going to be about 6.3 repeating, I believe. So let's see here. So 38 divided by 6. Yeah, 6.3 repeating. Because it would be 6 and 2/6 left over. So then it'd be 6 1/3, 6.333 repeating. So it's about equal to 6.33. So these are our solutions, our x-intercepts, -3 and 6.33 for this one. Okay. So this is just us going through all of the strategies of solving quadratics and trying to think of what would be the best strategy when faced with certain equations. All right, so we have 2 more left. So this one here, let's first see if it is factorable. Okay, which means that it works with the diamond I'm going to draw here. So if I draw this diamond, I'm going to have -6x squared on top and positive 2x on the bottom. So if I think of all the numbers that multiply, let's do all of them that multiply to -6 because there's not too many. We could have a +1 times -6, or -1 times +6, or +2 times -3, or -2 times +3. And then if you add those, this one would be a -5, a +5, -1, and a +1. None of them are 2. So this does not work. Does not work. And same thing here. Since the 2 is the coefficient of x squared, we cannot complete the square. We cannot. Okay? So here, what we're going to do is use the quadratic formula again. So I'm just going to copy and paste some of the stuff I wrote here, just so I don't have to rewrite everything again. And we have more room to work with here too. Okay. And then again, this is the standard equation. All right, so if anything, you can like set it like right underneath it or something. Let me move these others out of the way. I want to leave this here, these notes here, just so you can see like what had happened and why we ended up having to use the quadratic formula, okay? So the quadratic formula, first we identify A, B, and C. And again, please remember to pause the video if I go too fast because I'm going at a faster speed than I would be in class. So the A here is 2, the B is also 2, and the C is -3. And if you don't see that, it's these coefficients here, here, and here. Okay? So now what we're going to do is plug it into the quadratic formula. So we have x equals negative, instead of b, I'm putting in a +2, plus or minus the square root of b squared, 2 squared, minus 4 times a times c is 2 times -3. You see how sometimes I don't draw my square root sign long enough, so I just extend it once I'm all done writing everything that's within the square root sign. And then here we have 2 times 2. Okay, and again, here you could still be color coding if it helps you see visually what you substituted into the equation. If you don't understand what you're substituting in, please color code until you really grasp that understanding. It's very important. All right, so now this one is negative times +2 is just a -2, plus or minus the square root. We have 2 squared, so 2 squared is 4. And then we have -4 times 2 times -3. That is -8 times -3, which is +24. All over +4. So now all that we can simplify inside is the -2 plus or minus. This would be 28 all over 4. Now, we have to write it in exact form and approximate form. So what we can do here is see, is root 28 a perfect square? Okay, so let's go and plug it into Desmos. We'll do the square root of 28. It is not a perfect square. So now I want us to think of some factors of 28. Well, let's see here. If I split this up into 2, the square root of 2 times the square root of, it'd be 2 times 14. I still get the same thing, right? But 2 and 14, neither of those are perfect squares. So I'm trying to think of, okay, what other factors of 28 is a perfect square? So if we take the factors here of 28, we have 1 and 28, 2 and 14. And then we have, let's see here if I can make that a bit smaller. Okay. And then we have 4 and 7, 5, 6. Yeah, this is it here. So we want to look at these numbers here and see, okay, where is a perfect square at? Well, if you've done all your perfect square homework and took our notes, you'll know 4 is a perfect square. So we have to split root 28 up into root 4 times root 7. And I'm going to prove to you why it's still equal to root 28. So just like here, if we split this up to root 4 times root 7, it's totally legal. Look, we get this exact same number, 5.29150262, and so on, right? So we get the exact same number. So we are allowed to do this. So we're going to split root 28 into root 4 times root 7. Now we are simplifying the radical. Root 4 is really just 2. The square root of 4 is 2. And then we still have times root 7 here. So now we're one step closer to writing the simplified version of this equation. So here we can simplify this down to x equals negative 2 plus or minus 2 root 7 all over 4. Now I notice that 2 and 2 are both even numbers, and 4 is divided by each of those, by 2. So what we can do is rewrite this as negative 2 over 4 plus or minus 2 root 7 over 4. Just to kind of help you see how to simplify so that you didn't only simplify like these two and you didn't only simplify those two and then forget about whatever the other 2 was in the numerator. But here I know these 2 are both divisible by 2, so this becomes a 1 and this becomes a 2. 2/4 is really just equal to 1/2. Same thing here, 2 and 4. That is just 1/2. So now we have negative 1/2 plus or minus 1 root 7 over 2. Now, since those two fractions have the same denominator, we can rewrite this once again. We can rewrite this as x equals negative 1 plus or minus root 7, because 1 times root 7 is just root 7, all over 2. This is totally legal. So whenever you have two terms being added or subtracted in the numerator, you have to split them up in such a way just like I did up above, okay? Otherwise it won't work. So you have to make sure you're very meticulous and careful with splitting up your fractions and simplifying your terms there. So now we can split this for the plus or minus. That's what we're splitting it for. We're going to have x equals negative 1 plus root 7 all over 2, and x equals negative 1 minus root 7 all over 2. And now we can plug this into the calculator because this is the exact answer up above. And now we're going to go get the approximate answers. Okay. Whoa, sorry, I did not mean to do that. I hit my little arrow by accident. Whoops. There we go. Okay, sorry about that. All right, so if I go into Desmos, I have 1 plus root 7 all over 2. Let's see what happens here. So if I just write it like that, look at what happens. That looks nothing like my work. So, okay, so I'll do divide by 2. Nope, still does not look like my work. So in order to divide the entire top by 2, you have to put the top in parentheses. And now it'll put the 2 underneath the entire numerator there. So this is about equal to 1.82. So negative 1 plus root 7 is 1.82. Oh, shoot, it is negative 1. Excuse me. I don't think I've ever said shoot in a video. All right, so this is a negative 1. I'm sorry. Negative 1 plus root 7 all over 2 is 0.822. Okay, so it would be a 0.822. So we'll just round it to the nearest hundredth there, 0.82. And then we have negative 1 minus root 7. Negative 1 minus root 7. Oops, see there? Sometimes it's a little finicky, so I have to like click out of the root and then put the parenthesis there. And this is all divided by 2. So now this one is negative 1.82. So negative 1.82. So these are my answers. Now on the EST, like for say, like if you at least give me the decimals, that's totally fine. You can go and get the decimals directly from if you were to split this one up. So you don't necessarily have to simplify for the EST, but it is helpful if you know how to do that, because you will be required to do that in the future. All right, so once again, let's test if if basic factoring would work here. So I'm going to have x squared all over 6x. This is 1. The only thing that would be here is 1 times 1. So it definitely does not work, right? However, completing the square, we meet the criteria. A equals 1, check. B is even, check. B is 6. Let's complete the square. We all need the practice, okay? So this one is tricky, but it's so important because you will soon be using it to write the equations of circles. So it's a very important skill that you must have. All right, so I'm just going to leave that there so you can see it, and I'm going to rewrite x squared plus 6x plus 1 equals 0. Now you know that we have taken notes on completing the square, so if you need to, go pull up the notes, print them out, have them open on your Chromebook, whatever you need to do. So here's the first step. I'm going to go through rather quickly, so make sure you have your own notes out. I'm going to subtract the 1 from both sides to get the c term out of the way. So we have x squared plus 6x blank equals negative 1. So now in order to complete this square, I have to add b over 2 squared to both sides. My b here is a 6. 6 over 2 is 3. 3 squared is 9. So I am adding 9 to both sides of the equation here. So this is for me to be able to complete the square. So I have x squared plus 6x plus 9 equals negative 1 plus 9 is 8. And now I can write this as a perfect square. So to write it as a perfect square, it's x plus half of the b, parentheses squared. Half of my b here is 6. Or I'm sorry, my b here is 6. Half of my b then would be a 3. So this is my function. Now I have not finished solving the equation though, okay? So we still have to solve for x. So now that I have this, x plus 3 squared equals 8, I can take the square root of both sides, plus or minus. So now I have x plus 3 equals root 8. Oh, plus or minus root 8. I almost forgot that. So now I have to subtract 3 from both sides, and so I don't forget the plus or minus again, I always put the whatever I moved it back over in front of that square root. So here I'm going to have x equals negative 3 plus or minus root 8. Now I can simplify this a little bit more because 8 has factors 2 times 4. 4 is a perfect square. So let's see here. If we take the square root of 8 and we split it up to root 4 times root 2, root 4 is 2 and root 2 just stays as root 2. So I could rewrite this x equals negative 3 plus or minus root 8 as 2 root 2. And this is what we would call simplified radical form. This is a simplified radical. This definitely takes practice, all right? So here now I'm going to split it. Remember, please pause if I'm going quickly for you. So we have x equals negative 3 plus 2 root 2. That might be a little bit too bright for you. Here, I'll write in another color. X equals negative 3 plus 2 root 2. And x equals negative 3 minus 2 root 2. So we want to plug that into the calculator because we're definitely going to get a decimal. So here we're going to have negative 3 plus 2 root 2. Oops, I don't think I meant to. 2. There we go. Okay. And then we have negative 3 minus 2 root 2. Oops, forgot 3 there. There we go. Okay, so it looks like I have negative 0.17 and negative 5.8. 3. That 8 after the 2 bumps up the 2. So it'd be negative 5.83. What was the other one? Negative 0.17. All right. So these are our solutions. And that's where I'm going to stop here for the notes. That was longer than I thought it would be. But these are all the different strategies. So we did 1 completing the square. We did 2 quadratic formula. And I added on one of the basic factoring ones here so you can see what happens whenever it does work out. Okay? If you have any questions, please email me and review the videos and class lectures anytime you need some extra.